Hello everyone, welcome to One Star Mathematical Solutions. Today we are going to see about countable sets. A set A is said to be countable if it is either finite or denumerable set. We have already seen what these sets are. If you want to see, you can check out the playlist. A is said to be countable if it is either empty or it is equivalent to a subset of natural numbers or it is equivalent to the natural numbers itself. If any of these happens, then it is called a countable set. Okay, so let us see some important results on countable sets. The first result is A is finite and B is a subset of A. This implies B is also finite. That is, every subset of a finite set is finite. Second one is that A and B are finite sets. Then A intersection B is also finite. Can you see why this is happening? Because A, B is here and A intersection B is a subset of A as well as B, right? So since every subset of a finite set is finite, A intersection B is finite. Okay. Third result is every subset of a countable set is also countable. As in the case of finite set, this is also true for countable. Okay. Fourth result is every infinite subset of a denumerable set is denumerable. What do you mean by denumerable? It is equivalent to the natural numbers, right? Then any infinite subsets will also be equivalent to natural numbers. Fifth one is if A and B are countable, then their intersection A intersection B is also countable. And every infinite set has a countable subset. Okay. The next one is if A and B are countable, then the union A union B is also countable. Next one, the union of denumerable sets. It's also denumerable. Next result is that finite set is not equivalent to any of its proper subsets. But in the case of infinite sets, every infinite set is equivalent to its proper subset. So this is subset. Now let us see some examples. The first one is the set of all rational numbers. This is countable. The set of all positive rational function numbers is also countable. And the set n cross n. This is also countable. Fourth one is set of all polynomials up to a degree n with rational coefficients. This is also countable. This can be written as a set of all p of x, which is of the form a0 a1x plus etc plus an x power n, where all the coefficient ai belongs to q and this, the number of elements in this is nothing but q cross etc. q n times. Okay, the number of elements in this is equal to the number of elements in n product of q. Okay, since q is countable and finite product of countable sets is countable, we can say that this set is countable. The next example is the set of all intervals a b, where a comma b is a rational number. This is a countable set because the number of elements in this set is equal to the number of elements in q cross q. We know that q is countable and the product is also countable, so it is a countable set. Next example, the set of all algebraic numbers is a countable set. Thank you guys, see you next time.